Okay, I'm back. Sorry, don't know what happened there. I guess I lost my place. Yeah, this river continuum concept is trying to show you longitudinal flow of energy and material. So in low order streams in this range here, what you're finding is lots of the carbon is in the coarse particulate organic matter form. This is like large chunks of detritus from trees and branches and so on. It's coming into the stream from the riparian corridor. Most of the carbon in a low order stream is coming from elsewhere. It's coming from the riparian area or the upland around. Then as that carbon moves downstream, you see these little spring-like things. The material's getting cycled. They call these nutrient spirals because that carbon's getting chewed up by organisms like shredders, little organisms in the stream that are chewing this up and pooping it out. And then the next organism is eating their poop and pooping it out, and it gets processed as it goes down the stream until it becomes DOM or FPOM. DOM is dissolved organic matter, and FPOM is fine particulate organic matter. So coarse stuff like leaves and branches and dead raccoons and things are getting chewed up and pooped out and processed as it moves downstream. You see in very tiny print here, it says P to R less than 1. So that's the photosynthesis to respiration ratio. And it's less than 1 in this case because not much sunlight is hitting the water. So there's not a lot of photosynthesis going on in the actual water. Most of the photosynthesis is going on in the stream riparian corridor, the plants along the stream, and that carbon is falling into the stream. So the P to R ratio of this actual stream itself is less than 1. Respiration is happening because of all this processing, but not much photosynthesis in the stream. If you move down to a middle order stream, still the spiraling is happening. Now most of that stuff is dissolved or fine particulate stuff because it's passed through the bodies of several organisms along the way. Now you see P to R is greater than 1. That's because more sunlight is hitting the water in a medium order stream. There's more photosynthesis. This word periphyton means algae that are growing on rocks or mud or sticks or logs or plants, algae that are growing in the stream and doing photosynthesis. So most of the carbon here, still there's some coming from the outside, but a lot of the carbon was actually fixed by photosynthesis in the stream at this point. The organisms in these boxes are meant to be invertebrates, and in a smaller order stream, they're dominated by shredders, especially in the eastern streams like we have here in Ohio, that are chewing up large bits of coarse particulate organic matter. As you move down to a middle order stream, now it's dominated by collectors. Collectors are organisms that are picking up bits of detritus, fine particulate stuff that's floating down the water, and scrapers, which are scraping algae off of rocks and things like that. The shredders are now not nearly as important because there's less coarse particulate stuff. When you get down to a very large order stream, 7, 8, 9, 10, now it's mostly phytoplankton and very fine and dissolved carbon. There's almost no coarse stuff. Sure, there might be a log or a dead body or something floating down the river, but for the most part, it's very fine particulate stuff. And it's mostly collectors and then the predators that eat them. There's no scrapers, there's no shredders. Interestingly, if you look at the P to R ratio here, it's less than 1 again. And you might think, why is that? There's lots of sunlight hitting the water, and that's true, but it doesn't penetrate very far into the water because the water is really muddy and murky. The sunlight might penetrate only a centimeter or 2. So there's really not, most of that river is dark down in the depths. So there's not much photosynthesis going on in the river. So P to R is less than 1 again. So P to R goes from being less than 1 to greater than 1 to less than 1 in this model. So this is the river continuum concept. It explains a lot of things about streams. It's been around now since 1980, and a lot of people have measured these things and found them to be pretty accurate. We'll find out next time, though, it doesn't really cover a lot of the things. All it really covers is the longitudinal exchange. It doesn't really consider much lateral exchange. And the next model we'll look at, the next concept of rivers we'll look at is called the flood pulse concept, and that kind of attaches the river to the riparian corridor alongside. Okay, so river continuum concept is a really important concept for you to know in river ecology. Here's a little picture of it that shows the rivers coming together and a lot of processing happening, and then things moving longitudinally. So these arrows are trying to show processing, the little nutrient spirals, and then things moving longitudinally. The next model we'll look at next time is obviously the flood pulses bringing in material from the floodplain. Okay, so that's it for today. Your assignment is to do some reading on this. So if you haven't already, find the Freshwater Ecology book. It's abbreviated FE in the syllabus. It's a book we haven't looked at yet, so you're going to have to find it through the Denison Library System. Hopefully you're able to access that. Chapters 5 and 22, I think, are about stream ecology. And then I posted on Notebowl a chapter that I find to be pretty useful by Richardson and Moore. It's called Stream and Riparian Ecology. It covers some of the same things, but it does it in a slightly different way. And it gives you a nice background on stream ecology. We will do a stream ecology lab of sorts this week. I will introduce that on Wednesday. So you can look forward to that and for the sequel to this little video coming out on Wednesday. In the meantime, if you're having trouble with any of this, hearing me or seeing me or accessing this material or finding the book, let me know and we can try to remedy that. Don't wait for too much time to go on because I don't want you to fall too far behind as these start to pile up. Also stay well. Hopefully you are well and you're with people that are doing well and your family's okay. It's a difficult time for all of us, but we'll find a way to get through it. Just stay away from other people, I think, and wash your hands, as everyone says. So until next time, I will sign out. Bye.